Okay, 7.3 log laws. So on your guys' formula sheet, you guys should have something like this. Actually, you should have this because I snipped this from the 30-2 formula sheet. And this is really what this is on. And I know this looks really confusing, but it's actually not as bad as you think when you get looking at it. It's a little bit funny when you're looking at it with the the letters like the M and the N and everything else, right? But here's the idea is if I had something written like this, if I had, like, I'll just do like an example of the first one here. If I had something written like log base, whatever, this is base B, right? So log base, I'll call it base 2 or something. And then and maybe I'll make this, 6 times 7. Then what the first log law is saying is that if you've got something written out in that form, right? So this is like your B and the 6 is my M and the 7 is my N there in that case, then that would actually be equal to actually just splitting these guys up. I could write this out as just log base 2, so base B, right? It's the same base of 6, right? That's like the M and the M there. And then plus log base 2 of, and then 7. So in the end, do you see that they're just saying that log base 6 times 7 is the same thing as saying log base 2 of 6 plus log base 2 of 7? So that's just our first log law, is that you can split those guys up. You can write them either way. Yeah, so that's your first log law. Getting into the second one here, very similar, actually. This one's just saying if you had something like log, I'll do base 2 again, keep it consistent, base 2 of 7 over 6, or something like that, like something divided by something else, then that could actually be written as log base 2 of 7, and then instead of a division, it's minus log base 2 of 6. Okay, and this should look kind of familiar. And where these actually come from, remember how exponents and logs actually have some stuff in common? I'm not going to get too into exactly why, but why this works with multiplying turning into addition and division turning into subtraction there. It's the same reason that if I had or I'll actually make a number. Let's say we had like 2 to the power of 4 times 2 to the power of 6. Do you remember what we did there? If you have the same base that you added the exponents, that'd be the same thing as 2 to the power of 10, right? So when you multiply, you would add. So this is actually the same type of thing going on. It's for the same reason that we end up with these log laws. And then similarly, if I go, let's say like 2 to the power of 7 divided by 2 to the power of 4. So when you're dividing those, you would subtract. And that's why, the same reason we get division and subtraction coming into play here. But yeah, for the most part, you guys just need to know that these are the rules and how they use them there. So, okay, so those are our first two. And then the third one is this. So if I had a situation like, log base 2 of, let's say, 4 to the power of 3. Okay, either like that with the bracket on the outside or the bracket around the 4, either one would be the same thing. So here's this log law. You see the only difference between these is that the n that is up in the exponent here is actually down in front now. So that n, you can just grab it and throw it down in front of the log. So in this case, it'd be the same thing as taking this exponent on the 4, and then we can just put it back down in front of the log there. So that'd be the same as 3 log base 2 of 4. Okay. So now the one thing we got to get good at, though, is you got to go back and forth. We're going to have to be able to like switch it up, like going from this form to that form or that form to that form. So we got to be able to go either way. So I think for the most part, let's just do some examples and do that. So, all right, I'm actually going to grab a few from your assessment here. So let's do one like this. So let's say that we had, it said simplify 2 log 5 minus 2 log x. Okay, so it could be an x or it could be numbers, right? So I was doing numbers above, but it can be variables too, okay? So where do we start here? So I can see, first off, the base. Like, what is my base on both of these? I never actually even wrote anything. Typically, you'd have a number down there, right? Like base 2 was what that one was. So if there's nothing written on it, it's implied that it's base 10. So it's actually like a 10 down there for both of them. But I'll just leave it like that, right? So they're the same thing. Now, typically, looking at this, if I've got, this minus this one, well, that sure looks a lot like that, right? Where I've got log base 2 of 7 minus log base 2 of 6. So I could almost just call that same thing, just like, 7 over 6 or x over 5. But the problem here is these 2's out front. So what I'm actually going to do instead is I'm going to grab these 2's and I'm going to move them up. I'm going to put them up on the 5. So I'm going to grab that one. I'm going to put it up on the 5. That is this log law. So it's going to put it up to the top there, and then rewrite it. So that'd be the same thing as log base 10, I guess, but it's log 5 squared minus log x squared. Okay, so now, yeah, that's pretty much it. Now we can do our log law. So doing our second log law here, when you're subtracting bases or logs with the same base, then they can be written as a division statement, right? Subtraction and division go together. So that'd be the same thing, writing it as a single log, as log, and then this one divided by this one. So 5 squared over x squared. Or you could actually square it and say log of 25 over x squared. And there you go. There's your combined log law there. Okay, so there's one. Let's do another. All right, so let's do one like this. So we'll say, yeah, that'll be good. So we'll do log base 7. Nope. Log base 7 of 9x plus log base 7 of 12x to the power of 6. Okay, so thinking of my log laws here, same base. I'm always checking for that, right? I couldn't do this at all if it didn't have the same base, but they do. So base 7, and this really reminds me of our second log law, right? This is this one here. So first log law. If I'm adding, then that's the same thing. I could just rewrite those as m times n. So in my case, that's just going to be 9x times 12x to the power of 6. And just a multiple. So let's just do that first. So as a single log, that would be log base 7 of 9x times 12x to the 6. Now I just need to clean this up. I need to actually multiply those guys out, right? So we've got log base 7 of 108, and then x times x to the 6. So remember, you would add the exponents there, right? That would be x to the 7. There you go. There's our combined log there, or written as a single log. Okay, let's do another one. So we'll say, let's go the other way now. So let's say that we had an expression like log of x to the power of 17, y to the power of 11, over z to the power of 7. All right, so now we've actually got 2 steps here, because we've actually got a couple things going on. We've got a multiplication happening, right? X times y, and we've got a division happening. So this is actually going to use all 3 in the end before we're done here. But let's just do them one at a time. So I've got x times y. So remember, according to our log law there, if it was times y, we can write them as separate logs, but it's going to be an addition sign instead. So that was, oh, come on. That was this one, right? So it's going to be written as an addition. So we'll do that part first. So this would just be log of x to the power of 17. And then plus, right? Because it's multiplying, so it's going to be adding, plus log of y to the power of 11. And then it's as simple as this, where now if you've got like a division, anything on the bottom here, like anything that we were dividing by, would have a just subtractions. This is going to be minus log z to the 7. Okay, now that's good, but like on your assessment there, it's written like this. It says write your answer like a log x plus b log y plus c log z, right? So it wants it in that form. So what the difference is here is that the way I have it, I don't really actually have any like any coefficients out front of these logs yet. So I want to, well, put these these numbers that are the exponents down now, right? So I'm going to bring the 17 down, I'm going to bring the 11 down, I'm going to bring the 7 down. Okay, so writing that out, this would all be 17 log x plus 11 log y, and then minus 7 log z. So now one thing to watch out for in this question though is like it said write it in this form. Well, actually, sorry, it'll say write it in this form, and then what are the values maybe of a, b, and c. So in that case, right, this is my a, that's my b, and that's my c. So you'd say this is 17, this is 11, and then your c value, even though it says like plus c, right, I ended up with -7, so that would be -7. So that's the way your answers would go in when you get to this question. All right. So I think that's pretty good for those questions. Well, I'll just do a few more here. These are actually old diploma questions, so they're going to be good to go through. So it says when the expression log base b of 32 minus log base b of 7 and b is greater than 1 is written in the form log b of a, then the value of a to the nearest hundredth is. All right, so what's going on there? So really what we got to do is we've got to combine these guys. And the way we got to combine them, well, I'm subtracting. So I'm going to use that second log law. I need to divide, right? So it's going to be this. So if it was written as a subtraction statement, we're going to rewrite it in that form. So that'll be log b of, and then it's just 32 divided by 7. Okay, and then it says, what's the value of a? Okay, well, all of this is a. So really the answer here would just be a is going to be equal to 32 divided by 7. So you just punch that in, and you would get 4.57 because it's to the nearest hundredth, right? It's the 100th spot. All right, next one. So the logarithmic equation 2 log a of b is equal to c, where a is greater than 1. You know, one thing I never mentioned above too, this whole where a is greater than 1, don't get too lost in that part of it, right? That's just kind of necessary, where they're just saying your base can't be 0, right? Your base has to be some number greater than 1. That doesn't really affect what you're going to do here, but okay, either way. So it says rewriting this, so we can express this in exponential form. Okay, so this requires that we use one of our log laws, and then once we have our log law set up, then we can write it in exponential form. So we did that in one of the earlier units. So what I'm going to do is I'm going to rewrite this guy, but I am going to move this 2 up to the top. Okay, so this is going to be log a of b to the power of 2 is equal to c. Okay, so now we have to remind ourselves now when we're doing this, and sorry, this is on your formula sheet too. You can actually see straight from your formula sheet how to convert this. It's probably worth going to it. So just one sec. So on your formula sheet there, you can see right here, right? It actually spells it out. So log A of y is equal to x. So let's use that. And the way I always think about it is I draw this little picture where it's like A, because it's the base, right? The base will always be the base on both of them. So it's A to the power of C is equal to that part. So I kind of draw that arrow in my mind all the time. So I've got A to the power of C is equal to B squared. So do we have that one? A to the power of C is equal to B squared. Yep, got it. It's weird there for a second. Okay, so that'd be that one. Okay, last one, then we're done. So we've got these different expressions, right? All kind of written out. And now it says the expression with the largest numerical value is numbered what? And the expression with the smallest numeric value is measured or is numbered what? All right. Well, one little thing I might recommend doing here, I don't know if it's cheating or not, but you could just make up any number you like and actually put some numbers in and just actually try it, right? You could actually put in, 2 for R and put in 2 for every one of the R's and actually just plug it in your calculator and figure out which one ends up giving you the bigger and the smaller numbers there, right? But the other way you can look at it is let's rearrange this just a little bit. So let's say that we had this first one. I'm going to rewrite that with a 3 up top. Okay, so this would be the same thing as saying log base R of R to the power of 3. Okay, we'll just leave it like that for a second. Now we'll look at the next one. So let's write the next one out. This would be the same thing as saying log base R of, well, and then R times R, that's actually just R squared, isn't it? You can leave it like R times R if you like, but it's going to be nice to compare these if they're both with exponents like that. Okay, and the next one. So the next one here is going to be log base R of, if I cancel those, right? Cancel one R with one on the bottom, I end up with 1 over R. And then the bottom one here, log base R of, and then R divided by R, they'd both cancel. And that's actually just 1. Okay, so then I'm going to ask myself, I'm going to remind myself, what are logs? Logs solve for exponents, right? So this is saying R, right, the base there, to the power of something is equal to R to the 3. Okay, well that something's going to have to be, really in this case, my biggest number, right? That's going to have to be my biggest number right there, right? To get R to the power of 3, to get a big number there. So R to the power, well, actually, it's going to have to be 3, isn't it? This would be R to the power of 3 would give you R to the power of 3. So that one would actually, you can tell that's going to be 3, okay? In this case, we can see, okay, R to the power of 2, right, is going to be that one. This one would have to be R to the power of, well, that'd be -1, wouldn't it? Right? Because remember, the negative exponent would flip that guy upside down. That's like saying R to the power of -1 would be 1 over R. Okay? And then the very last one, this would be R to the power of, and then what gives you 0? Gives you 1? That'd be R to the power of 0. Anything to the power of 0 gives you 1. So now that I have these things written out, I can kind of see a little bit more clearly. Like I said, if you didn't like thinking in terms of like R there, you could have actually put any number you like in, right? Put a 2 in for all of them. You would have actually got these same numbers out of it in the end. Okay, so now that we have that, it says the expression with the largest numeric value is number. So the largest would be 1. Okay, so it's going to be 1. So it's either A or B. And the smallest numerical value, well, that'd be the -1. So that's going to be 3. So the answer here would be A. All right. So that's it. Yeah, just make sure you guys do your online homework questions.